Uh, we are still discussing about compressed air system optimization as this a case study in for a coal-fired power plant, and then this is the my sixth presentation, and then today uh, I'm going to talk about the generating cost of compressor. The most important things, or the most significant thing that we had to do with the compressed air system optimization is to calculate the cost, yeah, to analyze about the cost of operational of air compressor. And then here in this presentation, I have calculated and I have estimate and then all of the parameters that related to the cost of operating compressor. And uh, here, as you can see, generating cost of compressor, we can put in this graph. You can see in this graph, and the green one, the the green one is cost that related to the current to the current operation, uh, and then the blue one, this is the cost related to if we have implement some of the energy efficiency recommendation. So from this graph you can see that there is a little difference here that we call this the saving. If you're running the compressor as usual, as business as usual, as it happened today, um, the cost to generate this compressed air system per year is about 4 billion, yeah, 4.2 billion rupiah. But if you implement some of energy efficiency that I have proposed in this project, in this study, the cost will reduce up to 3.9 billion rupiahs. So it is uh, it will save about 300 something, 300 million rupees. So you can see that in this y axis, you can see the cost estimate, generating cost in rupiah, and then in x axis you can see the online capacity cubic feet per minute. So the cost is from here, you know that the cost is related to the capacity, why the capacity is varies here, because as I explained in already explained in the previous presentation, um, here in this case there are four compressor. There are mainly there are two compressor room. Each of compressor room consists of three compressor, and then but only two compressor operating, yeah, only two compressor operating in each compressor room. So totally there are four compressor, but in actual uh, they will not operate all of the compressor, yeah. They will not operate all of the compressor, but the compressor is operate depend on the demand side, depend on the demand of the air compressed from the user, from end user. So for example, let's start from the morning, yeah. Starting from in the morning, usually the only one compressor operating, yeah. Only one compressor operating, because the in the starting time, maybe in early in the morning there are just only a few activities, yeah. But gradually with uh, the demand will increase gradually, and then we have to running more compressor here, yeah. We have to running more compressor here, and then the with the increase of the operating compressor, the cost also increase, yeah. It is linear, yeah. It is it is depending, the cost is depend on the online capacity of compressed air. So here this graph is, we can create in the Excel, yeah. You can create this graph in the Excel. Maybe you can put some equation in the Excel, then we can simulate the cost in this Excel. Let's talk about the quality of compressed air. Most of people, most of the operator in industrial, uh, they already know that the compressed air, the parameter of the parameter operation of compressed air just only in pressure, yeah, just only pressure and flow rate maybe, yeah. Sometimes they focus on the pressure only, yeah. Pressure, how many pressure of compressed air they need, yeah, they required, or they produce from the compressed air. But they don't talk about a lot about other parameters, yes, such as maybe flow rate, such as water content, particle content, and oil content, also temperature of compressed air. Yeah, because all of these parameter is also significant. Uh, it will impact to the operating cost, yeah. This parameter also will impact to the maintenance cost also, the maintenance cost. For example, if the water content of the compressed air is quite high, yeah, it will affect the life of the piping maybe, yeah, the life of the solenoid valve, because they will degrade, yeah, degrade because due to the corrosion, because the high content of water in the system. So we have also to take a lot of these things, yeah, quality of compressed air to this, and then as you can see here, in for example in this graph, this is in one case, yeah, one case in one location, yeah. During summer, yeah, during summer, when the temperature is about 25 degrees Celsius, the ambient temperature is about 25, and then the relative humidity is about 80%. Yeah. So we have water content, or H2O. H2O is water content, is about 23.5 gram per meter cubic. 23.405 gram per meter cubic of water content. Water content per meter cubic. 23 gram per meter cubic. Yeah. We had a significant amount of water here. So let's say, for example, if we have to deliver deliver air about 10 meter cubic, 10 meter cubic with pressure 1 bar. So this is the intake condition, yeah, the intake condition. Every 10 meter cubic, every 10 meter cubic of air in 1 bar. This is ambient condition with temperature about 25 degrees Celsius and relative humidity 80%. This air will consist of water about 184.4 gram. 184.4 gram. Yeah. So it is the significant amount of water that have to be delivered to compressor, to the air compressor, every 10 meter cubic. Yeah, every 10 meter cubic. And then the compressor will compress the air, and the volume will reduce. Yeah, the volume will reduce. Yeah. Due to the compressor, due to the compress action, compress steps, the air will reducing the air will reduce, the volume of air will reduce, yeah, from 10 meter cubic to 1 meter cubic. Yeah, almost 1/10. Yeah, 1/10. And then but the water content is still the same. Yeah, about 184.4 gram. Yeah, for gram, 4 gram per meter cubic, for 1 meter cubic. Why in 1 meter cubic consists of 184.4 gram? Yeah, because the reducing of the volume, yeah, the reducing of the volume of air, yeah, not reducing the water content. Yeah, will not reducing the water content. The water content is still the same. Yeah, still the same, unless, yeah, unless we drain this water, content from the air to the outside of the system. Yeah, unless we drain this water content to outside, yeah, to outside of the system, so the water content in the air will be reducing. But up until now, because the process just only to compress, the process in air compressor just only compress it, yeah, compressing of the air, so the water is not eliminate. Yeah, the water is not drained to outside of the system. Yeah, okay. After out of compressor, yeah, the air produced from the compressor will flow to the dryer system here. Yeah, to the dryer, or cooling agent, yeah, for the dryer. And then for example, here this air is cooled to 5 degrees Celsius, yeah, to the 5 degrees Celsius. Yeah. And then with this process, yeah, for example, in this process, it will take in the refrigerant dryer, yeah, in refrigerant dryer, the water content in the air, in the form of moisture. Yeah, you have to note that from here up until here, from the outside, from the ambient up until the outside, outtake of compressor, discharge of compressed air, discharge of air compressor, the water content in the air is in the form of moisture or vapor, but because the cooling effect, yeah, the cooling effect here in the refrigeration dryer, the water will, the form of water will will change, yeah, will change from the moisture or vapor become fluid, yeah, become fluid. We can see, we can say this process is a condensation, yeah. We can say this process condensation. A condensation process will take place here in the in the refrigerant dryer. So uh, we will get the significant amount of water here, yeah. Every 10 meter cubic of ambient of air intake will produce about here in the refrigerant dryer, we'll deliberate, yeah, we'll deliberate, we will get about 177.6 gram of condensate, which means this is the water in form of liquid, yeah. The water content moisture that change become the liquid. The process is condensation, and then the product we call this the product as the product is a condensate, yeah, condensate. The condensate is the product of condensation. Okay, so here the water content in the compressed air will reduce. Here there are only 6.8 gram left, yeah, in the compressed air, yeah. There are only 6.8 gram of water left in the compressed air. This reducing because the water is condensed, yeah, condensed in the refrigerant dryer. Here the compressed air, for example, here they will flow to the absorption dryer here, to absorption dryer. This is the other type of dryer, yeah, different type, yeah. In previous type is the refrigeration dryer, and then in this type it is the absorption dryer. This absorption dryer have higher capacity to remove, yeah, higher capacity to remove water content from the air, depend on better than the refrigerant dryer, higher capacity than refrigerant dryer to remove the water content on the in the air. So here the water content will reduce, the moisture content will reduce, yeah, will remove will remove from the absorption dryer. So out of the absorption dryer, yeah, after absorption dryer, the water content will reduce up to 0.068 gram per meter cubic, yeah. Significant reducing of the water content in the air. Now we just only have the air, the compressed air just only have 0.068 gram per meter cubic, yeah. So here we in the same, with the same pressure, yeah, which is this is the pressure is 10 bar, the same here, it's 10 bar. 10 bar is the pressure result from the compressed state here, yeah. 1 meter cubic and 10 bar gauge pressure after the compress after the absorption dryer will have just only 0.038 gram of water content. It is a small, very small amount of the water content. It is equivalent to about only 2.81% relative humidity, 0.21% relative humidity, yeah. if we take a look to the initial condition, yeah, initial condition is the ambient condition. Here we in the initial condition, the relative humidity is about 80%, 80%. But here reducing quite significant, yeah, quite significant, up to 0.21% relative humidity. So here this condition of air is dried air. Yeah? We have a dried air here. Yeah. In initial condition, the condition we call this wet condition, wet air. Wet air after after this process, yeah, after this air flow to the several states, yes, several states of process, the air become dried air, yeah, dried air with the water content is about only 0.038 gram per meter cubic. We couldn't eliminate all of the water content. Maybe we still possible to eliminate all of the water content, but the process will be more complicated and more expensive, also more complicated, and maybe more energy needed. Yeah, more energy needed to 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 process, to remove all of the water. But this level is quite good. Yeah, it's this number is quite good, and then this number appropriate, yeah, regarding to the standard, yeah, regarding to the standard. Okay, here the my presentation is about quality of compressed air. Next we will talk about standards, yeah, the standard related to standard, yeah, standard that related to the air quality, yeah, to the air quality.